Hope my screen is visible for you. Yes, no? Please confirm this. Okay then. So let's get it started. So we are discussing about what Java collections. So the collection framework series is going on, and today we are going to discuss about the stack data structure. Right? Let me show you the program. Let me show you the architecture. So under collection framework, under collection interface, we have we have a list interface. So we have completed discussing about this array list, and the discussion was also done for linked list. Today we are going to discuss something about what the stack, right? So stack. So by looking at this picture, you will have to say that you can add few points. So what are the points that we can add by looking at this picture? Stack is a class. So no, stack is a class. It extends vector class, right? It is a part of collection framework. Right, so you can add these many points just by looking at this diagram. Yes or no? Let me copy this and paste it. Okay. So by looking at the picture, we are able to write the 3 points. The first point is stack is a class and it extends vector class. It is a part of collection interface. Okay, let me add the fourth point. The fourth point is going to be what? It was introduced JDK 1.0. Okay, so when the Java was introduced, the stack was already a concept that was made available in JDK 1.0, right? So when the Java was started, the stack was already there. Stack is one of the classes that came with the JDK 1.0 library. I can also say that the stack is the legacy class or the oldest class, right? When anything, okay, if you identify anything that was introduced in JDK 1.0 or the Java first version or the Java first release, when you identify any class or when you identify any interfaces, when you identify anything that was part of JDK 1.0, we usually call them as the legacy ones. So by using the word legacy, I can conclude that stack is a legacy class. Legacy means it was there when the Java was introduced. Right? Is anyone joined, Justin? Okay. So this is what the legacy means. Right? So we are able to write down 5 points. So the actual point will start from here. Okay. So the actual point is, so please stay focused on this point. Very, very important point to understand the stack data structure. It is using what? It is using a methodology to store elements. It is using a methodology to store elements, and the name of the methodology is LIFO. Okay, LIFO is an acronym of, the moment you hear the word LIFO, I'm not sure if you have heard this in your graduation days. So the moment you hear the word LIFO stands for, or LIFO is an acronym for, LIFO stands for last in, first out. So internally, stack is following a methodology, and the name of the methodology is what? The LIFO. LIFO is an acronym for what? Last in, first out. So what exactly the acronym is really doing with the stack class? What exactly the acronym has to do with this stack class? What does it mean? So in your college days, and in your school days, I can say, so if you want to do the homework submission, so you have a teacher and teacher usually sits in front of the table, right? And so there are students. So let us say that, so we have this many students in a particular class. So you are given a homework, right? You are given a homework and you are asked to submit the homework in the next day, right? Since you are good students, you do what? You follow this teacher's instruction, and the teacher is asking you to submit the homework, right? So homework will be written in the book, right? I mean, a kind of, we call it as the homework book or the classroom book. Each and every student, they carry the book. Let us say that it's a homework book. You as a student, so if this is the book, let me write it down here. Focus here. Okay, you as a student, okay, if you have written the homework or if you have completed the homework in a book, right? This book is what? Homework, HW, right? So after completing, you don't throw this book on the table, right, from the place where you are sitting. Are you going to do that? If you're going to do that, definitely teacher gets pissed off and you will get the respective treatment. What you do? Okay, you carry the book along with you. So the first person, he carries the book along with him, right? And the first person will submit the book on the table. Likewise, and the homework of the second person, okay, carries the book and submit the table, right? And the third person carries the book and submit on top of the table, right? So all the books are submitted in the orderly fashion, yes or no? From bottom to top. So all these books are stacked, one on top of one book, or, one after the another. All the books are stacked one on the another, yes or no? Books are stacked together one on the another. It looks like a vertical tower, isn't it? So as soon as teachers finds the stack of books, right? And this is a teacher. Just imagine that this is a teacher. A teacher finds the books are arranged in the orderly fashion. All books are stacked together, right? So what teacher is going to do? The last book that was submitted, right? Which is the last book that has been submitted? This is the last book that has been submitted. Yes or no? So this last book was submitted is going to be the first book that will be corrected. Are you getting this? Right? The second last book that was submitted is going to be the second book that will be corrected. The third last book that was submitted is going to be the third last book that will be corrected by the teacher. Yes or no? Don't you think that this is representing this kind of analogy is called as what? The LIFO analogy or the LIFO methodology? Last in, first out. Right? So same principle, the stack class is also following this same principles to store the objects or to store the data or to store the elements. Same analogy is being followed by what? The stack class, right? So the moment, let me remove this. Okay, I hope you got what does it mean when I say LIFO. LIFO means last in, first out. The books that are example, this is a books example, right? So you can take this as an example for the imagination, and we will try to work around the problems and see how these things work internally, right? Let me delete this, and we have what, see, these are the classes. So I hope you understood what is LIFO. Now this stack is coming up with three important methods. Stack is coming up with what? Three important methods. What are the three important methods? Okay, let me write down here. Methods in Java stack. Okay, so what is the first method? First method is what? Public void push method. What is the first method? Public void push method object element. Right? So let me write a class. Inside this class, I want to store, I want to take the stack class. So this stack class is going to accept what? This is the generic type, string type, and let me keep the object reference variable name as books. So new stack. Let me create the object. So this instruction is doing something behind the scenes. So when I do this, the moment I do this, right? So just imagine in your mind that, the stack key, for the foundation for the stack is created. When I say foundation, just imagine that a kind of a table thing. The foundation for the stack is created just because of this particular line. When you create an object for the stack, a kind of foundation layer gets created, and there will be a cursor. There will be a cursor. Okay? This cursor is pointing to a value that is assumed to be what? -1. Please remember this. Okay, the name of the cursor is what? Top. So what did I just say? What did I just say? The moment you create a class, the moment you create the stack class by using generic type, okay, this instruction is going to do something behind the scenes. Okay, this instruction has done something behind the scenes. A kind of table has been created, and along with the table, a cursor is also created. A cursor is also created, and the name of the cursor is what? This name of the cursor is typically called as top. Okay, it always points to the top reference. For now, since there are no books added, the value of top is going to be what? -1. Because the table is empty, the stack is empty, nothing is added here. Right? Now what I'm going to do? Okay, first I want to add something into the stack. Means I just want to arrange something in the stack order or in the vertical tower, or by using the LIFO methodology, last in first out. Just imagine that previous books example. Right? So what I'm trying to do here, focus here. Now I want to add a book. Books.java. I'm sorry, books.push. I want to push a book. Okay, the name of the book is, let me take the book as Java. Right? So like this, I want to add, how many books I want to add? I want to add 4 books. To keep it very simple, let us take Python, right? And let us take C, right? And the last book is C++. Okay, these are my favorite languages, that's why I'm taking these books. You can take your own books if you have any favorite things. So we have some instructions in the program. So these are our instructions, right? Good, so far so good. So we want to add something by using what? By using the push method. So this push method does the same thing that was previously done by the student. Previously, students, each and every student has done what? They did submitted that homework on the table in the orderly fashion, one after the another. So I can say that all the books are stacked on top of each other. Right? So but the moment I say, it finds the instruction, okay, this books is a reference variable of type stack, okay, and push is a method. Okay, what does it really mean? So behind the scenes, an object gets created, right? And the name of the object is what? Typically, this name of the object is going to be what? What is the first instruction? Java, isn't it? Okay, so this is the name of the object, Java, right? So you are pushing the book. This push is a method. This push is a method. It is used on top of books reference variable, right? And again, this books reference variable is a type of stack. What does it mean? So this book is ready to be stacked on the table. Okay, so the push operation is making this to be stacked as soon as it is added. So you can also consider it like an element is getting added, but in which order? In the stacking order. Right? Java has been added. As soon as this is added, right, the cursor will be moved here, because the cursor will be always pointing to the topmost element on the stack. So for now, the topmost element is what? Java. Right? So now this becomes what? Top. Right? So what is the value that we had previously? -1. So the topmost element is Java, but the index begins with 0. So this is a kind of thing, indexing concept. Okay, -1 means, so it is going to be 0. Why 0? We don't know. This is internal things. You can start indexing from 1 also, and again if you start from 1, so this is it's going to become. These are the internal things. Okay, so I think we are done with this. Successfully we have pushed an object. Okay, next thing is I want to push what? I want to push Python, right? So what is the name of the book this time? Right, so name of the book is Python. So Python is an object according to this context. Python is an object. So this object is being pushed of which data type? Of the stack data type, right? Type is stack. So it is going to follow LIFO. Will be pushed, right? So cursor will be pointing to the recently placed object, and now this is going to be top. Okay, the moment this top is getting changed from time to time, right? And the indexing will also be changed. On this time, the index is going to be 1, right? Likewise, what are the other two books we have? What is the third one? C book, right? What is the fourth book? C++ book, C++, right? So these books gets added on top, right? So now top becomes what? Now this becomes top, isn't it? Top becomes what? This, and the index gets created accordingly. Okay, now the index is what? 2, right? What is the last one? Last one is C++, isn't it? So C++ will be stacked here, right? And at the top is going to be, this is going to be top, right? So let me move this to keep some space for the cursor, right? Yes, right, and this is top, and the cursor will point to the top. Always it will point to the top, right? And what is the name of the last book? C++, and indexing is going to be what? 3, 0, 1, 2, 3. So our operation is successful now, right? So these things, the things that we have done here, okay, the instructions that we have given here has been stored in the RAM in such a way that it has followed the what? It has followed the LIFO methodology, last in first out methodology, one on the another, right? The moment I give the system.out.println statement, okay, the moment I give system.out.println statement, and I want to print all the books, name of all the books. Okay? And if you see something, if you observe, if you notice something here, so the order of the book is preserved. Okay, see, Java has been added first, Java, Python, C++. Okay, the order is being maintained. So see, the moment I try to do this, let me copy this and paste it here. So the moment I try to do this, so it is maintaining the insertion order. So you might be getting a doubt. The C++ needs to be printed first because of LIFO. No, printing wise, the cursor will be right. The toString method will be overridden in such a way that internally it is going to start from the 0th index and it will extract the value of the object, and Java will be printed first and Python will be printed second, C will be printed third, C++ will be printed fourth. Right, when you want to print, okay, so I have always said in the previous classes, especially in the class where we were discussing about toString method. Okay, when you just give the reference variable, it is not about the reference variable. It is going to do what? It is going to call toString method. So this toString method is overridden in such a way that when you call the toString method, okay, the top cursor will be reset from the beginning, will be resetted from the 0th index, and it will extract all the values from the order that we have placed. Have you understood about the printing? How does it gets printed when you call the reference variable? Are we good till now? So we have a lot to. We have only a few more concepts to discuss. Are we good till now? Everyone, type us in the chat box if you are able to follow me. Right. So now focus here. So we have understood public void push element. Okay, what does it mean? The push method. The push method is used to push an object into the stack class. Right, push an object into the stack class, and all the objects will be arranged accordingly by following LIFO principle, or I can say that LIFO methodology. Okay, so principle. Please be informed that when you try to print the reference variable of the stack class, it will override the toString method, and the values will be extracted and printed from bottom to top. This is the internal thing. It doesn't mean that it is violating the LIFO principle. We will understand that shortly. Okay, this is the internal thing. Reference pair, so it will override the toString method. Okay, and the values will be extracted and printed from bottom to top. So it doesn't mean that it is violating the LIFO principle. So this is all about what push method. So now we are going to understand about what the pop method. Public return type is object and pop. So when I say pop, so it means what? It means removing an element in the stack. Okay, so try to understand this. Let's see who is going to answer to my question. For example, okay, this is good. This is looking good. For example, let us say that. So let me import something. Okay. So I have. These are the stack of books. Stack of books we have, right? These are arranged. Okay. And if you want to take one book out of it, so how we are supposed to take? Okay. So if you want to take this green color book, so you as a human being, we directly pull that. No issues. You as a human, you can directly pull that. So if there are a lot of books that are arranged in this order. For example, if there are 50 number of books that are arranged in this order, what you do? If you want to take the green book, first you will take red outside, right? Then you will take yellow outside. Then you will take blue book outside, and then you will take green book outside, isn't it? So when you want to remove something, okay, the topmost book has to be removed. Then you can look for your relevant book that is required for you. Yes or no? So pop operation also does the same thing. It is going to remove an object. It is going to remove an object from the top. Okay. Pop method is going to do what? It is going to follow LIFO principle. What does it mean? Last in, first out. Okay. It is going to remove an element, or it is going to delete an element that is always on the top. Right? Now you tell me by looking at this, okay, if I use books dot pop, if I use this method, which object will be deleted? If I use this method and if I print this again, right? Let me repeat this for you. If I use this method, I am clearly saying that top object will be removed, right? Now you tell me which object will be removed. Java, Python, C, C++, which one will be removed? Answer to me. Mixed answers I am getting. What about others? You're getting my question, I guess, right? Push method is going to add an element. Pop method is going to remove an element from the top. So according to the nature of the objects that we have added, which object is going to get removed when I use pop method? Jyoti, yes, says Java. Come on, guys. How long it is going to take to type Java and C++ Python? Come on, everyone. Samyukta, Jyoti, and okay, let me answer. I don't know. You're not getting this. Okay, so let us go back to the same thing. Delete. and delete. Let me delete this. Very simple, guys. Why you are taking a lot of time to answer to this particular question? So the moment I use pop method, so already we have stack of books. Already we have stack of books. Okay, let us imagine that this is the object. Okay, already we have stack of books. What is the topmost element? Topmost object C++. C++ will be popped out. C++ will be popped out. When C++ is getting popped out, right? There is no concept of indexing. When there is no concept of indexing, the top value will be now. Now C is what? The top value. Now the cursor will be pointing there. Okay. This has been deleted. This has been what? This has been deleted. I can say that this has been garbage collected. Right? If I print this, right? What is the missing element? C++ is missing element because it was on the top. This object was the last object. This object was the lastly added object. What does it mean? Since it is a lastly added object, LIFO stands for last in first out. When you delete an element from this particular reference variable, this has to come out first. So that is deleted. If I do pop for the second time, okay, if I do pop for the second time, okay, let me do pop for the second time. Okay, and let me print. Same thing. Right? Now C will be removed. Yes or no? Now C will be removed. Java Python remains there. Okay, if I do this for 2 consecutive times, right? Now I should get what? Empty stack. Stack is empty. And again, if I do the pop operation on the empty stack, if I do pop operation on the empty stack, right? You get exception. What is that exception? Java.util.empty stack exception. If you are trying to remove something, you are trying to remove an object, but there is no object available in the stack. So that's why it is giving an exception. It is just like this. If you go back to the program, you are removing all the objects one after the another. Okay, it follows LIFO principle. Okay, by using pop method, all the objects are removed successfully. So and again you are trying to use the pop method, and it is trying to remove something, and there is no element because the index has become -1. The stack is empty. So that's why you are getting what? You are getting the exception like java.util.empty stack exception. Right? Making sense? Let us keep this. Right? So let us limit this program to this. Okay, and again observe one more thing. So if I am not placing this pop method inside the system.out.println statement, okay, if I try to place this pop method inside the system.out.println statement, so right, I am trying to do what? So I want to do this operation, but this time I want to do this in the system.out.println statement. Okay, it is going to return something. What it is going to return? What is the return type? Object type. Object type. So when there is something like return type here, okay, you can do that operation in the system.out.println statement, and it is going to give you something. Okay, this time it is going to give me, right, the deleted element it is returning. It is returning something. What is that something? The deleted element. Right? You have an option to extract that data. Okay, instead of doing this, I can also do the other way. What is that other way? Right? Object and what? Object deleted element equal to books.pop. Okay, it is going to return me something. What is that something? The element that is the object that is going to get deleted. So C++ is going to get popped out. C++ is going to get deleted. I am catching that element by using the reference variable name deleted element. Okay, when I do system.out.println, if I want to print this deleted element, I will be getting the element that is already deleted. C++. Right? So what are the points that I can write here? The pop method is used to delete an element, delete an object, the stack. and the topmost object will be deleted, and it is also going to return the deleted element. The return type is object type, right? And what is the condition that we have? Please be informed that if the pop operation is performed on an empty stack, you get what error? What was the error that we have just got? Books.pop. Okay, let me remove all this. So I just want to, I'm trying to catch that error. That's it. Okay, you get the java.util.empty stack exception. Get the following exception. This. Right. So we got to know what is the use of pop method, and there is another method called as what? The peek method. What is it? Public object peek. Right. This peek method is a kind of method. So where you will see that there is no difference between the peek and pop method, but there is a lot of difference between peek and pop. So when I do peek method, so when I use peek method, and let me remove this. We have understood what are these things, right? The moment you do pop method, it is going to remove the last element, last or added element, or the recently added element. Where is the proof? So this is the proof, right? It is removing, and so when you do this in the system.out.println, right, you will be able to see which element has been removed. So C++ has been removed, right? And try to print it once again, right? So see what is happening behind the scenes, right? So this book reference is going to print all the elements in the orderly fashion: Java, Python, C, C++. Good. And this pop method is going to delete the topmost element, and also it is going to do what? It is going to return which element has been deleted, C++ code. After that, again we are trying to print books. Now this time we have Java, Python, and C. Okay. Now if I try to use system.out.println books.peek. Okay, so peek method is also going to return me the topmost element. Now what is the recent topmost element? Go back to the diagram. Okay, what peek method will do, guys? Peek method will return you the topmost element. It can see even if you arrange some books in the form of stack. So if you want to see from the top angle, what is the book that you can see? This time I am able to see the book by the name of C language, right? This book is visible to me when I try to look into the stack from the top angle, right? Same thing it is doing. So it is going to return the object that is on the top. So C will be, but it will not be deleted. It will not be deleted. Pop will delete this. Pop will do what? When you perform the pop operation on the current object, it will remove this, and it will return the object name of, value of the object that is removed, that is being removed. But the peek is not like that. What peek is going to do? It is going to tell you that C book is the topmost book on the stack cycle. Are you able to find the difference? If I run this code, right, and again if I try to print the list of books that are in the stack, so no elements will be removed. Okay, So see, after this I have performed the peek operation. Okay, it is returning the topmost object, right? And again I am trying to print. Okay, the value is there, the object still remains there. But when you do the pop operation, the object is getting removed and the removed object is being displayed in the console, right? But when you do the peek operation, okay, the topmost object will be printed and it will not be removed. That's the only difference. Peek is nothing but peeking to, I mean, peeks, I mean, what we call it as seeing something secretly, right? Are you able to follow? Yes, no, everyone? Are you getting this? Yeah. So peek method, okay. So please be, I mean, the above method is used to do what? Above method is used to return the value of the topmost object or the last object that was added the stack added by using stack principle using stack class, right? And it will not remove the element. Will not remove the element. Okay, what if I do the peek operation on an empty stack? What if I do the peek operation on an empty stack? Let me consider that. Okay, I do not have added any kind of objects, right? I have just have books and I just want to perform the peek operation on the empty object. Books dot peek. Okay, so empty stack exception, you get what? Empty stack exception. So I can do the same thing now, right? Nothing is there to be returned. So if something is there, it is going to return that. If there is nothing, it has to return something. So that something is what? An exception. So ideally I can say that we cannot perform the peek operation on the empty stack. Are you getting this? Please be informed that if the peek operation is performed on an empty stack, you get the following exception. So I think the same exception, isn't it? Right? So what is the next method that we have? We have a kind of what? The search method. Public int search method, and this is going to search for the particular object. So look at this, guys. How well the search method is designed inside this stack and stack methodology. So let me go back to the program. So let us go back to this previous example itself. So this is the previous example. Right? I want to search something like, so I have list of computer programming languages book, and this time I want to search a book like some.outer.println. Right? I want to search books dot search. Okay. I want to search what book? I want to search what book? I want to search physics book. Okay. Is there any physics book that has been added in the stack picture? No physics book, no such book, right? So when I try to perform the search operation, I want to check if the physics book is available or not. So what it is going to return? If it is available, it has written something. So if it is not available, it will return -1. Okay. What if it is available? What if it is available? If it's not available, we are getting -1. Right? Why it is giving us -1? Let us see when it is available. For example, I want to try looking for Java. Right? So it says 4. Means here the order has been reassigned. From top to bottom it is taking 1 2 3 4. Don't worry about these things, it is taking 4. You can consider this as from top to bottom. From top to bottom the order of Java is what? 4. From top to bottom. From top to bottom the order of Java is 4, isn't it? So previously we have C++. Let us assume that C++ was 1 and C is 2, Python is 3 and Java is 4. But if you do not have anything, it is running -1. So ideally when you do the search thing, right, when you do the search thing, it is returning the values in such a way. It is returning what? It is returning value in such a way that it is returning the value in the LIFO order. The order is what? Again, it is following what? LIFO. According to the LIFO order, the placeholder of Java is what? It is holding the fourth place. Because LIFO order is what? From top to bottom. Right? According to our example, we have 4 books added: Java, Python, C and C++. Isn't it? So these are the 4 books. Okay, according to right, first Java gets added, then Python. Okay, then we have what? Then we have C, right? Then we have what? Then we have C++, right? So according to the LIFO, it has to give us the numbering from top to bottom order. Okay, from top to bottom order. Okay, when it will search whether C++ is there. Yes, it is there. C++ is there. Okay. Count 1. C is there. Yes, I mean it will search for the Java from top to bottom. Okay. First search, count number 1. Second search 2. Third search 3. Fourth search 4. Yes, it is 4. It will return the count 4. Right. Previously, what was the search that we have did? We are looking for physics book. Yeah, again for the physics book, start from top. Okay, it has to check this. Okay, C++. This is not physics. Okay, so count is going to be 1. Okay, this is not physics. Count is going to be 2. This is not physics. Count is going to be 3. This is not physics. Count is going to be 4. Okay, nothing is left. Okay, what was the default count that we have? -1. That -1 will be returned. Right, for searching it will follow LIFO principle. For printing it is going to follow from bottom to top. From 0 to 1 it will follow from bottom to top. Are you getting this or not about the search method, everyone? Yes, no? Good. Right, so please be informed that for the search method it is going to return an integer value according to the order of LIFO principle. When the object is present, it will return the count of the object. If and object is not present, will return -1. Right, so this is the significance of what? This is the significance of the search method, the Java stack library. Right, and so we have 6 points here, and the 7th point is going to be what? Okay, so since it is extending what? Since it is extending vector class, all the properties and behaviors the vector class is applicable for the stack class. Right, so again the question is going to be, what is vector class? What is vector class? So this is going to be the last class in the list interface. Right, we are we haven't discussed about this vector class, so tomorrow we will discuss about this vector class. What I'm trying to say is, there are some properties and there are some methods in the vector class. Okay, you can use that methods or you can override that methods in the stack class also. Okay, so these are the prominent operations that you can do with the stack class. Okay, what are the prominent operations? What are the prominent methods that we have? We have push method, we have pop method, right, and we have peek method, and we have what? Search method. So you have other different methods. There are other methods that is not necessary for now. Okay, these are the methods that is created upon the stack class. right? Please remember this method: push, up, peak, and search. So this could be the questions that you face in the interview room, right? If you perform the demonstration the way that I have presented, definitely the interviewer is going to get impressed. Okay, do you have any questions for me for these, especially on top of this stack collection?